Okay, so what is the eccentricity? So eccentricity is nothing but it's a deviation from a established pattern. So how much you have deviated, the higher the eccentricity become. Sometimes people say it become eccentric. That means you are not in normal shape. Okay. So deviation from established pattern or something which is normal from a normal. That is called eccentricity. In case of a conic section, the eccentricity is defined with respect to a intersection of a cone and a plane. So suppose this is a plane, this is the base of cone, so obviously this is the plane, cutting plane, and we discussed this is the generator. We already discussed the generator of a cone. So let's say this angle alpha is with respect to the angle of a plane with respect to the base of the cone, and let's say this is the angle beta is the angle of a generator of a cone with respect to the base of the cone. So the eccentricity is defined sine alpha upon sine beta. Okay, clearly alpha is the angle of plane, cutting plane with respect to the base of cone, and beta is the angle of generator of cone with respect to the base of cone. This is how we define the eccentricity. And let's see what happened with the case of a circle. We know that in case of a circle, this cutting plane will be like this. So in this case we get a circle. In this case clearly the angle alpha is 0. Okay, we know that alpha is the angle of the plane with respect to the base of the cone. So clearly alpha is 0 here. Since alpha is 0, that's why E is equal to sine alpha upon sine beta turn out to be 0. So for a circle E is equal to 0. Let's talk about the ellipse. We know that for ellipse the cutting plane should be like this, and clearly we observe that suppose this is the base of the cone and this is the cutting plane, so obviously this is alpha and this is beta. Here we observe that the alpha is less than beta. Okay, for ellipse basically this will form a ellipse. So obviously alpha is less than beta, so E is equals to sine alpha upon sine beta will be less than 1. So for ellipse E should be less than 1 and greater than 0. Obviously E is a ratio, so E is a ratio, so it will always be a positive. So E will never be negative. That's why E value will be 0 for a circle, greater than 0, less than 1 for a ellipse. Similarly for a parabola, we discussed already in previous lectures that for a parabola the cutting plane should be parallel to the generator of a cone. That means suppose this is the alpha and this is the beta. Clearly here alpha is equal to beta, so E is sine alpha upon sine beta turn out to be 1. So that's why E is equals to 1 for a parabola. And let's discuss about the hyperbola. In case of hyperbola, this is the cutting plane. So if this is the cutting plane, this is the alpha and this is the beta. Clearly here alpha is greater than beta, so E is equals to sine alpha upon sine beta will be greater than 1. So for a hyperbola, E is greater than 1 for a hyperbola. Okay, so let's see the one animation. So here we can see here that as the plane is moving with respect to the cone, that is the alpha is changing, so we get a different conic section. Okay, see here this is now hyperbola because alpha is greater than beta, and as we move we get Now this is going to be a parabola, then ellipse, then circle. So let's go one by one. So basically here we have, in case of a cone, obviously here beta is fixed. We are not changing base of the cone, only we are moving the plane. So in this case we observe here that now the plane is alpha is 0. So this is the cutting plane. So this is the cutting plane and we are getting a circle. So in this case alpha is equal to 0 and we are getting a circle. Let's say the other case, and we move it to where, let's say we move it to yeah. Now here we observe that now this is the cutting plane is something like this, that is alpha, and obviously this is beta. Here alpha is less than beta, and we observe that E is obviously 1 and we are getting a ellipse. We see that the section is now a ellipse. Again let's move to the now here this is the case of a clearly alpha is equal to beta. So here alpha is equal to beta, and we are getting a parabola. Alpha is equal to beta, that means E is equals to 1. We are getting a parabola. We can see this, we have parabola. Now if we move ahead, so we get a hyperbola. So again now the cutting plane is like this. So obviously this is alpha, this is beta. Alpha is greater than beta, that is E is greater than 1, and we are getting we can see that we are getting a hyperbola. Okay, and as the value of E increases, we are getting, still we get a hyperbola, but see this hyper is greater than 1, we are getting hyperbola. So we can see here, we observe here the hyperbola. Parabola, ellipse, circle, ellipse, parabola, hyperbola. This is how it moves. Okay. Basically we observe that E is equal to 0 for a circle. We derived E is equals to 1 for a parabola. E less than 1 and greater than 0 is ellipse, and E greater than 1 is a hyperbola. Okay, so what we observe here, the interesting thing, optical eccentricity is 0, this is ellipse eccentricity is 0 to 1, and if we increase more it will turn out to be a parabola, and for E is higher, more higher, greater than 1, it becomes a hyperbola. So basically what is meant by eccentricity? So eccentricity, clearly eccentricity is a measure of how much conic section deviates from circle. Conic section deviates from circle from being circular. Okay, so E is 0, perfectly fine, and the more the deviation from a circle, we get a ellipse. So if we deviate more, we get a, so here we have little bit deviated from a circle, so its value is greater than 0 obviously, but less than 1. If we deviate more, let's say I have deviated more, parabola, so obviously E is equals to 1, and if we more deviate from the circular, E is greater than 1, that becomes a this circular, ellipse, elliptic nature, parabola, and this is a hyperbola. So what I mean to that, the eccentricity is the measure of how much a conic section deviates from being a circular. Okay, that means as the value of, we can see that the as the E increases, conic section deviates from circle, E is equal to 0 to very high value, to hyperbola. That is E is high, very high. The higher the value of E, higher this deviation from a circle. So that is the one of the significance of E. The more the E, higher the deviation from a circle. One more significance of E is important here, is the significance of E, let's see, is the shape. So this E signifies the shape of section, conic section. That means, what it means? It means that the same value of E implies conic section will be similar. Okay. For example, let's say circle. This is circle. Acha, by the way, you should understand that if I say that the same shape and same size, we say the congruent figure. Okay, shapes. And if I have only a same shape, we say the similar figures or similar geometry. For example, if you say this circle, smaller circle and the bigger circle, so these two circles obviously are similar, they are similar figures. Okay, so E is here, E is equal to 0, and here E is equal to 0. So E is equal to 0 for both the circles. That's why we say that both the circles are similar, and obviously circles are similar. And if same way, parabola, either it's a small parabola or bigger parabola, obviously E is equal to 1 and E is equal to, so we'll say that these two parabolas are similar. In fact, we can say that all the circles have a eccentricity 0 and all the parabolas is eccentricity 1. So all the circles and the parabolas, are similar. Okay, whatever parabola is there, whatever the size, obviously whatever parabola you will draw, they will always be a same shape. Obviously their size will be different, but they will be same shape. So that's why all the circles have eccentricity 0 and all the parabolas have eccentricity 1, so they all are similar. Two conic section, conics with same eccentricity are similar. Okay, for example, let's say I draw one ellipse. So obviously we find out the value of E is, let's say, 0.5, and if we draw something different ellipse but it eccentricity is, let's say, 0.5, we say that these two ellipses are similar. These two ellipses are similar. Why these two ellipses are similar? Because they have the same value of eccentricity, the same value of E. That means whatever is the conic section, if their values of E is same, we will say that these two conic sections are similar. Okay. But important thing is, since all the circles in the universe or all the parabolas in the universe all have the value of E is same, because all the circles have E is equal to 0, so all the circles in the universe are similar. Similarly, all the parabolas have a value e is equal to 1, so we'll say that whatever the parabola it is doesn't matter, they will be similar. But in case of ellipse on hyperbola, e will be different, because e will be anything from 0 to 1 case of ellipse, or e will be anything greater than 1 for a hyperbola. So we'll not say that all the circles, all the ellipses are similar. Obviously different e will have a different ellipse will have different e value, but if the values of e is same in case of ellipse, we'll say that these two ellipses having same value of e are similar. Same with the hyperbola as well. If the two hyperbolas having the values of eccentricity are same, we will say that the two hyperbolas are similar. So let's talk about the eccentricity of degenerate conics. So we already know that we have defined the eccentricity is sine alpha upon sine beta, where so this was a plane, cutting plane, and this is angle alpha and this is angle beta. Now for a degenerate conics, this particular cutting plane will pass through the vertex. So let's say what we discussed, the alpha 0, e was 0, and they represent a circle. But what happens in case of degenerate conic section? In case of a degenerate conic section, our cutting plane will be like this. Now in this case, the conic section will be a point. But what about e? Here, since this is a point, okay, this is being a point, here we are not able to draw this, that is angle beta, and again that is alpha beta is not defined here, okay, because this is just a point, okay. So here we say that for if the conic section is point, e is not defined, undefined, okay. Similarly, if the cutting plane is this one, so in this case, that is e will be less than 1, greater than 0, so that represent a ellipse for a non-degenerate case. But for a degenerate case, they represent a point. So for degenerate case, they represent a point, elliptic point, okay. But what about the e? Here again e is not defined, undefined, because this is just a point. If this is a point, how can we draw a plane, or the, we can say, generator, okay, this being a point. What we know that for the, if the degenerate case, degenerate conics is point, e is undefined. Now is equal to beta case, we know that e is equal to 1, it represent a parabola, and for a degenerate conics, the cutting plane will passes through the vertex like this. So here alpha is equals to beta, okay, alpha is equal to beta, so they represent a line. So obviously here the degenerate case conics will be a line, and e is equals to sine alpha upon sine beta is equal to, because this is just a line, okay, so alpha is equal to beta. What if alpha is less than beta? What if alpha is greater than beta? We know that e is greater than beta, and the non-degenerate case is hyperbola. Degenerate case, again this is alpha, this is beta, clearly e will be sine alpha upon sine beta is greater than 1, because alpha is greater than beta. So let's say for a non-degenerate case, okay, we discussed that E is equal to 0, circle, E is equal to 1, parabola, E less than 1, greater than 0, ellipse, and E greater than 1, hyperbola. But whereas if you talk about the degenerate case, let's talk about the degenerate case. For a degenerate case, we have a point, okay, that E is not defined, undefined. Whereas for straight line, E is equal to 1. For a pair of straight lines, E is greater than 1. Okay. So basically, E is equal to 1. The degenerate case of E is equal to 1 is a straight line, whereas non-degenerate case of E is equal to 1 is a parabola. Whereas the degenerate case of E greater than 1 is a pair of straight line, whereas the non-degenerate case is a hyperbola. For E, point, so E, you should know E is equal to 0 or less than 1. E is equal to 0 is the circle which is the non-degenerate case, but point is a degenerate case. But for a point, eccentricity is not defined. Similarly, E less than 1 and greater than 0, the non-degenerate case is an ellipse, whereas the degenerate case is a point for which the E is not defined. So you should note down that the degenerate case, eccentricity is only defined for a straight line and a pair of straight line, not for a point.